Hi, my name is Sude and I'm currently a physics student in Bilkent University. And today I will be showing you my Physics 102 lab experiment. The objective of this experiment is to measure and observe how the shape and size of capacitors affect their capacitance, as well as to examine how the state of the capacitor changes under different voltages. Here we have the formula that we will use in order to measure the capacitance on a capacitor. And in this formula, we can directly see that area and capacitance is directly proportional. As you can see from the figure, there's two different types of capacitors in which there's a flat capacitor and a cylindrical capacitor. We will also set up a cylindrical capacitor in order to examine how the shape of the capacitor changes the capacitance. And from the formula down below, Q equals C times V, we can directly see how the relationship between the charge and the voltage changes, which is directly proportional. So for this experiment, the required equipments are quite easy. First of all, we need paper and aluminum foil in order to build our capacitor. And we will need jumper wires to connect and multimeter to measure the voltage. And also it can measure the capacitance and also a power supply. So the procedure goes as this. First of all, we need to build our capacitor, and we will do it by placing a paper and then an aluminum foil on top, and then another paper and then another aluminum foil and paper again. And this setup will give us our capacitor. And after you tape the necessary pieces, the capacitor should look like this. We have built the flat capacitor, then we need to make the cylindrical capacitor, and it is quite easy. After you build your flat capacitor, if you just roll it, then you will have a cylindrical capacitor, in which I will show you in the next video. You have taken your datas. As you can see, here is mine. We can directly see how the stored charge increases with the increase in voltage. You can also examine the same trend for the cylindrical capacitor as well. I have a graph for the flat capacitor, and as you can see, we have successfully shown the linear relation between the charge and the voltage. Even though the overall aims of the experiment were successfully met and we have successfully shown the linear relation between charge and voltage, and also how the shape of the capacitor changes the capacitance, we still had some error. First of all, for the flat capacitor, we had an 18.2% error. And for the cylindrical capacitor, we had a larger error, which is 28.2%. These errors were probably happened because of the imperfect connections between materials. They could also happen due to the variations in the dielectric layers. There could have been an air gap while taping the capacitor. And rolling the flat capacitor to a cylindrical capacitor could have caused some errors as well, because the rolling would not be uneven. And also, basically, all of the above is happening due to human error. And we also have limitations to our measuring equipments as well. Even with these errors, we still have achieved a successful result in which we had effectively demonstrated how the shape of the capacitor and also the changes in voltage influences capacitance. And with more careful construction techniques and more precise instruments, we could have even closer values of experimental values to theoretical ones.